Alright guys, so this video is for the explanation of scientific notation. Most of us have done this before. We had a little quick overview on it not too long ago, but this is for the actual quiz and everything. And scientific notation is a form of writing very large or very small numbers that you've probably used in science or math class before. So in scientific notation, we just use the power of 10. You guys should be familiar with the power of 10 when we started doing pH and POH. We use the power of 10. We use scientific notation. So that is exactly what this is all about. Right? In scientific notation, what you do need to remember is first that the decimal point is put behind the first non-zero number. That means that from left to right, whatever number is the first non-zero number between 1 and 9, that's where you put your decimal point. Second, the power of 10 is the number of times it moved to get there. So if you moved it 3 times, then it's times 10 to the power of 3. If you moved it 4 times, times 10 to the power of 4, so on and so forth. A number that began large, meaning a number that's bigger than 1, has always a positive exponent. If a number started less than 1, it will have a negative exponent. That's what you definitely have to look out for. Okay, so these are the first example 1, and it says to write the following numbers in scientific notation. So how would we write these numbers? Like we said before, the first rule is you have to put the decimal point behind the first non-zero number. So if we're looking at this first set, this decimal point is going to go between 1 and 2. 1 is our first non-zero number. So this decimal has to be moved until this point right here. And we have to count how many times it took us to move that there. So it would be 1, 2, 3, 4. Okay, so our correct answer here would be 1.2457656 times 10 to the 4. Why is it positive? Why is it not negative? Because this number originally was way bigger than 1, as you can see that. And like I said, it took us 4 times, so that's why we put that exponent 4. Let's take a look at this one. So where would the decimal go now? Well, now the decimal doesn't go there because this is a 0. You have to put it to the first after the first non-zero number, which in this case is 6. So we're going to move our decimal point all the way over here. So how many times does it take us to move it there? 1, 2, 3, 4, 5. Okay, as you can see, it took us 5 times to get there. So how would we write it now? We would write 6.5423 times 10 to the 1, 2, 3, 4, 5, negative 5. Now this is negative. How come this is negative and not this? Again, this number started as a number that was smaller than 1. Let's go to the next one, 128.90. Where would we put this decimal? Again, we're going to put this decimal right here. That means that we're going to move it twice, 1, 2, and it's going to be 1.2890 times 10 to the positive 2. Again, why positive 2? Because 128 is a bigger number than 1. All right, so last but not least, where would we put the decimal here? Again, you're looking at your first non-zero number. In this case, it would be 7. So you would put your decimal there, and you have to count how many times it took you to move it there. 1, 2, 3, 4, 5, 6, 7. So it will be 7.532 times 10 to the negative 7. And again, remember, putting the negative is very, very important. How to read scientific notations. How do we know how to take a number out of scientific notation? Basically means that if you see a positive power, just like we said before, it's going to be a number that's bigger than 1, which means you're always going to move your decimal to the right. Now, if you see a negative exponent, that means that you're always going to move your decimal to the left. So be careful with that. Positive and negative don't move in the same way. So how would we take these? So now the second way of doing this is how do we take this out of scientific notation? This basically means that we move the decimal. We're going to either move decimal left or right. It all depends on what the exponent is. Is the exponent positive or is the exponent negative? So let's start with the first one. Exponent is positive. That means that we're always moving our decimal this way for the exponent because this is positive. So we're going to move it 4 times to the right. Okay, so if we were to start it would start up here and we're moving 1, 2, 3, 4. That means that we would add 2 zeros there. Anytime you're moving and there's nothing there, you're adding zeros, remember that, and then your decimal now would be at the end here. Okay, next one, 2. Again, positive, so that means that your exponent is moving this way. So where would you move it here? You would move it twice. So now your new number here would be 1, 2. That would be 287.5. Third one, as you can see, the exponent has changed now. It is now negative. That means that we're moving our decimal this way, and we are going to move it 5 times. So I'm just going to leave a little room here so you guys can see that. And I'm going to start writing 8755 here. It started here, so I'm going to move it 1, 2, 3, 4, 5. So it's going to have 1, 2, 3, 4. And I'm sorry I didn't leave enough space, but it is 4 zeros. And then your decimal now is going to be there. For this one, it's not really key that you have to include the decimal at the end. For these, however, the decimal does need to be included in your answer. So make sure, please make sure you put your decimals on there, especially for your quiz. Okay, let's try this one. So this is -3. Again, negative means decimal moves this way. All right, so I'm going to leave, again, some room there, and I'm going to start writing 7005, and the decimal started here. So we're going to move 1, 2, 3. That means that we're adding 2 zeros, and then we are adding our decimal there. Notation, how does this go hand in hand with significant digits? Scientific notation is more than just writing a shorthand. If you guys remember, we just finished significant digits, and what you need to understand is we skipped 2 problems, and you're going to know why right now. Because sometimes there's not a way to write a number, like once you've calculated something, multiplied or divided something, to write it with the correct number of significant figures unless you use scientific notation. To ask you to write, this is 120,004.25 with 3 significant figures. Okay, this is a number that you really can't write correctly with just 3 significant figures, and I'm going to show you why. So let's look at the first one. If we were to leave it like this, we know that all of this, it has 8 significant figures. The reason why is because we start from the first non-zero number, we go all the way to the end due to the fact that there is a decimal. Now, let's say, for example, we can round it to 120,000. Well, if we round it to 120,000 and we leave a decimal there and we cut off the 0.25, we have 6 significant figures. So we are not writing it correctly yet. Then, let's say I take away the decimal and I just write 120,000, no decimal. Well, in this case, it only has 2 significant figures because there is no decimal. You count from your first non-zero number to the last non-zero number, so that would be 2 significant figures there. Now, this is why scientific notation and significant digits go hand in hand. Because what we can do is write 1.20 times 10 to the 5th with 3 significant figures that way. Okay? And remember, we can't write it as just 120 because this isn't the same as saying 120,000. Remember, if you have $120, $120,000, that's a lot different. So remember, these zeros, just because they're not significant, it doesn't mean that they don't have to be there and that the answer can be incorrect. So in example 3, this is what you are going to be seeing on your quiz, something like this. I'm going to ask you to write the number of set of numbers in scientific notation with the correct number of significant digits that I've asked. So in the first one, I'm asking you to write 120,347.25 with in scientific notation with 3 significant digits. So how would we do that? First things first, you have to move the decimal to the first non-zero number. That means that this decimal is going to go here between 1 and 2, all right? So how many times do I have to move it? I moved it 1, 2, 3, 4, 5. So I have moved it 5 times, and I only want 3 significant figures. So that means that I technically only want these first 3, right? And so I'm going to cut off the 3. The 3 doesn't make the 0 round anywhere, so it doesn't matter. We just write it as 1.20 times 10 to the, again, 1, 2, 3, 4, 5. And that's it. All right, this is your first answer. Now let's do the next one. Again, Smaller number, smaller than 1, that means that we are going to have a negative exponent. Number was bigger than 1, that's why we have a positive exponent. So again, where are we going to move it to? We can't leave it there. We need to move it to the first non-zero number. So from left to right, our first non-zero number is 2. That means our decimal would go right here. And how many times did we move it? 1, 2, 3, 4. We moved it 4 times. We only want 2 significant figures. So technically we only want the 2.3. The 0 doesn't make the 3 round anywhere. So this would be 2.3 times 10 to the, again, 1, 2, 3, 4. That would be to the negative 4. All right. Next one. So this with 4 significant figures, where would we move it to? This decimal is going to go between the 1 and the 2. All right. So we have to count how many times we moved it. 1, 2, 3, 4. All right. And we want 4 significant figures. So this time we do want up to the 5 here. However, this 6, if you remember, makes the 5 round up. So in this case, we would have 1.206, okay, times 10 to the, and we have to count again, 1, 2, 3, 4. This is to the positive 4 because the number started as a number that was bigger than 1, okay? And last but not least, so we want 2 significant figures. We want the decimal all the way between the 2 and the 4. As you can see here, those are the only really 2 significant figures that we can write anyways. So let's see how many times we moved it. 1, 2, 3, 4, 5, 6, 7. So to the negative 7. 1, 2, 3, 4, 5, 6, 7. Just making sure. Always make sure of your work, okay, before you do turn it in. This is how your quiz will look like here. Let's practice, like the way that let's practice the last slide. If you guys take a look, I do want you guys to try these on your own. The first half will have something like this: rank the following numbers in scientific notation, and I will give you a number of how many significant figures I want there. The second half is just going to write out the following numbers out, meaning take them out of scientific notation. There's going to be obviously no significant figures here being asked. So please make sure you try these. Make sure you take a stab at these. And obviously answers are on the PowerPoint, and check your answers that way.